There we go. So we declare x as a symbolic variable, and this is integration. So let's run the section here and take a look at what it looks like. There we go. Yeah, x squared over 2. The integral of x is x. You know, that's the problem with algebraic notation, that if you follow the order of operations, this is like x squared, horizontal fraction bar, 2 on the bottom. But it's in computerese, on one line, they have to do it like this. It's like this is surrounded by parentheses. Remember order of operations, powers? Yes, that helps. When you use this command, just the way it's written, it does not enclose it in parentheses. So you got to be smart enough to interpret it well. That's all I did was just execute this command. And there we go. Integrate x. So this is just the integral, and of course you can do some really complicated things. What's the integral of cotangent? I don't remember what the integral of cotangent is. Takes a while to think. Okay. So you can put in expressions, you can integrate them. That's integration in symbolic notation. So you can do calculus in symbolic notation.
And EX is just because EX equals?
Expression. EX is just the name I chose. This, by the way, now I can use this expression in this command. So I'm going to go back here a second, rerun it. Now let's go to this command. What I'm doing here is I'm substituting 2 for wherever there's an x, I put 2 in this expression. The command is subs. Here in this section I also sub 3. You will see it will give us a fraction. It will still be symbolic. This is to convert it to a number. And then I redisplay the expression just to show you that symbolic expression hasn't changed. You're just converting it. You're just converting the answer to a number. Okay, so let's run this section. And we see in here, we've just substituted 2 in x, which gives us an answer of 2. In here, we substitute 3 in x. We see a fraction. To get a number that Matlab can work with, we just do the double. Or if you want an integer, you do int, whatever your data type is, int 16, int 8, unsigned integer, etc. Whatever your data type you want to be, or single, or something like that. Double is usually what people use. That's the default, is double. What's that now?
Where do you put in double?
Right here. Where'd it go?
There it is. Double.
There it is. Right there. Yeah. I substituted 3 into the expression, and I got this. I got 9/2. That's just a symbolic expression. So I convert it back to a number, a double answer. Let's do this. Let me do this. I'll create 2 sections. So I'll create the run this section. Now answer is still symbolic. So it writes 9 divided by 2. It writes 9 fraction bar 2, but it's still symbolic. You can see that up here. It's still symbolic. It's not until you do the double that you get a number.
Double answer?
Right, yeah. And the new answer now is now a number. Now the answer is a number. So this command is kind of important. Let's see, where is it? There it is. This is important to be able to convert your symbolic expressions to numbers. You also have to do a substitution. If you tried double EX exists, it's an expression. There we go. It's got an X variable in it. If I tried to double this, it wouldn't work. Get an error. Yeah. Okay. So you got to do the substitution. You got to have your answer in this kind of form. Now you can convert it to a double number that Matlab can work with like a number from then on. So that was one of the points I wanted to bring across today. Integration was one of them. This substitution was the second. This converting to a number, it was the third. This one just shows differentiation. So we've done integration. Let's take the derivative. Let's see if we get back the same answer. So run that section. So I integrated x squared over 2, which will give us x to the cubed over 6. And I differentiate it, I get x squared over 2 back. So it does derivatives, it does integrations. Okay. Now, you can do, this is 2 variables. I'm just creating a symbolic expression in 2 variables. I'm substituting for 1. And in this case, I'm going to substitute both x and y. And you got to use a cell array, which is what this is. When you're doing, when you're substituting for more than one variable, you got to do it this way. So let's take a look at that. So I'm creating a new expression in 2 variables. I substituted 2 for x. And so this becomes 2, and MATLAB calculates it and gives us a new expression. Now I'm taking this expression, and I'm substituting for x, I'm substituting 2, and for y, I'm substituting 3. And of course, this can be extended to z, w, I, j, k, etc. So you can have you can do as many substitutions as you want. So x is set to 2, y is set to 3, and that'll be 4 plus 9 is 13. Okay. So that's the last little bit I wanted to show about symbolic stuff. Any questions? So that's it for today. All I wanted to talk about. We do have evaluations we have to do. Any questions, though, before I send the evaluations out and hang out in the hall until you guys are done? No questions? Okay. I will definitely be available for individual